Hey everyone, today we're talking about how you can solve quadratic equations using the factorization method. So to start off, when you find the solution to a quadratic equation, you're actually finding what we're calling a root. So this is an important vocabulary word you should put into your notebook. A root is a solution to a quadratic equation. It is specifically a value of x that satisfies the equation ax squared plus bx plus c equals 0. So if you notice, your quadratic equation is being set equal to 0. And that's very important, and it's kind of like a neat way. It's helping us figure out the root in a neat way. Okay, because as we know, in order to figure out the answer, when you get an answer of 0, you really just need two numbers where one is equal to 0, right? Because anything multiplied by 0 is going to remain 0. So when we're looking at, let's say, two numbers that we're going to call p and q, if I multiply these two numbers p times q and I want to get to 0, then either p can equal to 0 or q can equal to 0. So using that little shortcut, we can easily figure out what the roots to a quadratic equation will be. And here's an example right here. Example 4 from your book. Solve the equation 2x squared minus 5x minus 3 equals 0. So we're going to ignore the equals 0 part for now and just try to factor this quadratic, 2x squared minus 5x minus 3. So if you notice, this is going to require us to either use the diamond box method or the AC method, which we talked about last time. So let's use the AC method. I don't feel in the mood to draw. If you remember, the AC method requires us to find a product where we get A times C, which is 2 times 3, which is 6. And we need to find the sum. That'll get us to this middle number, which is 5. Sorry, that'll be 2 times negative 3. My bad. Let me just redo this. Forgot about my negative signs. 2 times negative 3, my A times C, negative 6, and my sum is negative 5. All right, I need factors that'll multiply to get me to 6. So let's see, that's 1 and 6, 2 and 3. And then they also need to get me to the sum of negative 5. That's tricky, this one, because it could be 6 minus 1 to get me to 5, or 2 plus 3 to get me to 5. So let's see, then the signs really matter, right? So let's see, if I need to get to a negative 6, that means one of them needs to be negative. So that's going to help me figure out which one. Well, to get to negative 5 with 2 and 3, both of them have to be negative, right? So that the same signs, you add them. So that cancels out 2 and 3. I got to use 6 and 1 then. So that when I multiply, one of them is negative, and then when I add, one of them is negative. So to add and get to negative 5, the bigger number has to be negative. Okay, so then it's positive 1 plus negative 6. That'll get me to that negative 5. Okay, so then that means when I rewrite this problem, instead of minus 5x, I have 2x squared plus 1x minus 6x minus 3 equals 0. And then I can group these pairs together. So I have my x's taken out here. So that's 2x plus 1 minus 3, take that 3 out, so that'll be 2x, and then negative 3 times a positive 1 will be a negative 3 still. So I end up with x minus 3 times 2x plus 1 equals 0. Okay, so instead of 2x squared minus 5x minus 3, I'm left with x minus 3 times 2x plus 1. That should work out because, yeah, it works out. Okay. All right, now we're at this point. We got x minus 3 times 2x plus 1 equals 0. I'm going to rewrite that up there and erase all this so that you can see the rest of the work, because so far we've just factorized it. We actually have to solve for the roots. Remember the roots, now you're going to be able to figure out the solution. You'll be able to figure out answers for x. You'll get an actual value for x because it's being set equal to 0. And remember our rule from before, if we have two numbers multiplied together to get to 0, one of them just has to be 0. For instance, you could have 4 times 0, which will equal to 0, or you have 0 times, I don't know, any number, 7.5, and it'll still equal to 0. So as long as one of those factors are equal to 0, the answer will be 0. And guess what? You have two factors here. You have two quantities that are being multiplied together. There's technically a multiplication sign between these two. So the trick here then is to set each of these equal to 0. X minus 3 equals 0. 2x plus 1 equals 0. I just need to figure out what's a value that will make this quantity equal to 0 or make this quantity equal to 0. Okay, so if x minus 3 is equal to 0, then we're going to add 3 both sides, and x would have to equal to 3. That's my first root. X equals to 3. My second root is over here. I need to set 2x plus 1, this other binomial, equal to 0. Then I would subtract 1 on both sides. So then 2x equals 0 minus 1 is negative 1. Divide by 2 both sides. So x equals negative 1/2. So here are my two answers, 3 and negative 1/2. Let me just write them in like numerical order, okay? Just to be orderly. So I have my two roots right here. X equals negative 1/2 or 3. For both those values, you would satisfy this equation. But you're probably thinking to yourself, huh? How does that work? Let's go ahead and plug it into this problem then and see how it works, okay? I'm going to use a different color. So all I'm doing now is plugging in x equals negative 1/2. Okay, if x equals negative 1/2, I end up with negative 1/2 minus 3 times 2 times negative 1/2 plus 1. Set that equal to 0. Here you're going to get something nasty. Negative 1/2 minus 3 is negative 3.5. Doesn't really matter at this point. 2 times negative 1/2, these 2's cancel out because one's on the top, one's on the bottom, and you end up with negative 1 plus 1 equals 0. Look at that. Negative 1 plus 1 is equal to 0. So this ends up equaling to 0. Of course, over here we have negative 3.5. It don't matter though, because whatever is over here times 0 is still going to equal to 0. So that satisfies that equation, okay? When x is equal to negative 1/2, it makes this part right here, this binomial, equal to 0, and then it doesn't matter what the other binomial is, it's still going to multiply to 0. Okay, so that's if you plug in x equals negative 1/2. Okay, let's plug in x equals 3 because that's the other root that we found out. Now, if x equals 3, we'll have, instead of x minus 3, we have 3 minus 3 times 2 times 3 plus 1 equals 0. Look at that. 3 minus 3 is equal to 0. 2 times 3 is 6. 6 plus 1 is 7. Actually, doesn't matter what this number is because anything times 0 is going to equal to 0. So that root of x equals 3 also satisfies this equation. So basically, you're trying to figure out the two numbers that will, and usually it's 2 if you end up with 2 binomials. If you have three binomials, you'll just end up with 3 roots. So you have negative 1/2, which made this one equal to 0, and you had 3, which made this one equal to 0. So 2 different possibilities of multiplying to get to the answer of 0. One last problem. Solve the equation x times the quantity of 2 times x plus 1 equals x times the quantity of 3x minus 5. Pause the video, try it on your own first. All right, we got some distribution on both sides. So I end up with 2x squared plus x equals 3x squared minus 5x. I need to move stuff around. So let me subtract 2x squared. I'm moving everything to the right-hand side so I can get positive numbers. Because if I were to subtract 3x squared, I would get a negative, and I don't want to deal with that. Okay, so then I get x equals 1x squared, a positive x squared, minus 5x. I can subtract this x over here. So I end up with 0 over here equals x squared minus 6x. If you notice, there's no c value. Normally, it looks like this, right? But here we have no c value. It's gone. We like that, okay? Don't think like, oh gosh, this is going to be a terrible problem. No, this is good. This is a good thing. Because now you can just factor out the greatest common factor between these two. They just share an x in common. So we can take that out. So then we end up with x minus 6 inside, because x times x will get you that x squared. X times negative 6 will get you that minus 6x. Okay, and here you're done with your factoring. There's nothing else you can do because you were missing that c. And then here you already have 2 terms that are multiplied together. Let me write that in blue here, because technically this has a multiplication next to it. So it's really x times x minus 6. I can set both of those equal to 0. X equals 0 for the first one right here. And then x minus 6 equals 0 for this term right here. This is a multiplication problem. X equals 0 is your first answer. And then add 6 both sides for this one. You get x equals positive 6. So x equals 0 and 6. There you go. All done, because it was missing a c value.